Thank you very much. Hi, everybody. I am Josh Wood from CoreOS, as my first slide will tell you. While I work in San Francisco, I am originally from Kansas City, and I'm particularly excited to come and talk to you folks today. What we're going to cover is this idea of standardization of the container images that have become so popular and have become such an important part of our lives in DevOps over the last few years. That specification is being driven by an organization called the Open Containers Initiative, the OCI. And CoreOS, along with a number of our partners and competitors in the space, have been working on this for about 18 months. At CoreOS, we like to say we run the world's containers. You might know our operating system, Container Linux. It's kind of a minimalist container hypervisor, and it's expressly designed to run as compute nodes in things like Kubernetes clusters and other orchestration systems. So today we're going to talk about making containers portable, why we might want to do it, what standards are, what they're not, and what the outcomes of the effort to develop a portable container specification have been. So first of all, let's think about standards a little bit just in general. Standards define fundamentals around which an industry or a space can form consensus. Standards are not typically a complete platform for production or delivery. HTML is a pretty good example of this. HTML isn't the web browser that you use to view HTML pages, and it's not the tools, whether you mean a text editor or something like Hugo for rendering HTML or some kind of CMS system. It's actually the thing they produce and operate on. There's many different ways to create HTML, and there's actually a lot of different ways in a lot of Slack in how that HTML is rendered, but there's a basic agreed on idea of a standard that they can all operate on, produce, and execute. A friend of mine in a panel last week from Red Hat, I think, put it really well when he said, standards are about the boring things. So what are containers, and what are we trying to apply a standard to? Containers are discrete artifacts containing everything an application needs to run, like dependencies, libraries, and the executable itself. We like that idea because it allows us to isolate applications and their dependencies from the infrastructure on which we run them. That lets us migrate things around in automated ways, sort of the heart and essence of orchestration. What we want to do is prevent that from happening with 5 or 6 different container formats. Diverging implementations at this level can fragment the communities that we're trying to build around this DevOps idea, cause us to do redundant work, and worst of all for us, lock users and our consumers into platform choices over the long term. Why you need standards for containers is because there's a lot of interesting things happening actually in the execution environment for these containers. At CoreOS, we built a program, a CLI tool for executing containers we call Rocket, and it was really all about driving these kind of these standards discussions because we felt that one implementation, in this case Docker, the sort of de facto implementation, cannot possibly be a standard that competing and cooperating industry types can agree on and use in the way that HTML is or TCP/IP is for network communications. So let's take a little bit at the how we got here. Obviously, in the 2013 and 2014 era, Docker was really, really hot, lots and lots of mind share. They had this V1 image format that was easy to handle but not content addressable. It had a number of other missing features. During that same time frame, we at CoreOS started work on Rocket precisely because, A, we wanted to address what we felt were some missing features, but more importantly, we wanted to sort of convince the community that those kind of features are not really that interesting to talk about. What we want to talk about are the things we're looking at sort of on this slide that distinguish Rocket's ability to execute containers in different ways and under different isolation regimes. We wanted to be able to compete on those kinds of features without having to build a container standard that other tools and other infrastructure systems couldn't consume and use and it couldn't be migrated around easily. Rocket today has this historical standard that we created called AppC, the ACI format. It currently runs Docker images, and it runs this new standard that I'm here to tell you about, the OCI image, as that image develops towards its certification level. So this is sort of the ancestry of the OCI standard. Docker, CoreOS, Red Hat, many other players in the field, along with Microsoft, came together to kind of center around the Docker v2 format as a file system layout. and specify what is and is not in scope for defining a container image that not only infrastructure systems, but like to reference back to the last talk, tools that want to do introspection on containers. All of these kind of tasks are made much easier if that container image is a standard thing that we know how it's laid out on disk, how its layering works, and that no matter where it's being executed or what environment it's being orchestrated by, that image is a reliable standard piece, and we know how long it is, how tall it is, how high you can stack a number of them. And this slide gives a little evidence of me being very late getting my slides done. But we can talk about the things it does specify, like the file system layout, things it does not specify, like how distribution works, because things like registries, Docker Hub, Quay.io are considered to be outside the scope of the image format itself. And if you do check out my slides afterwards, you can get some more details from those URLs. That's a really difficult thing to run through with someone else controlling your slides. I hope you got a little bit of information out of it. We're hiring at CoreOS, and I encourage you to visit the Open Containers Initiative to take a look at this standard and figure out how to incorporate it with your tools. Thank you.
Thank you, Josh.